In this tutorial, I wanted to look at data types and why they're there and what different types there are normally found in programs. So, specifically, integers is pretty interesting because it has three different types of subsets. It has a short, it has a normal integer, and it has a long. So an integer is a whole number. You know, there's no trailing decimals. So, for example, 1, 2, 3, 45, negative, 78. Those are all integers. If I did 78.0 or sorry 0.2, that's not an integer. That's could be then a float or a double then. So an integer doesn't have any fractional equivalent. It's just simply a whole number. So then there's a certain amount of data a integer can hold, and I've written this line here that tells you how many numbers is in the minimum integer and the maximum integer you can have just using this type of data type. If you're using short, it would be less than that. But we're going to go ahead and compile the program after I save it. I have to remember to save these programs. So we're going to compile it, and then we're going to run it. And then it's going to enter a number from our previous video. And this is the range of which you can use integer values through. If you need larger than this, or obviously less than 21 million something, 214 million something. If you need less than that, you would want to use a long. A long is just simply an extension of the integer so that you have more numbers to play with there. I believe it's 2 to the power of 32 minus 1 for this, because 0 is included in the realm of positive integers. And then this is, you add 1 to that because, well, you don't add 1. It's 2 to the power of 32nd, but negative. So that's a short math foundations definition for you of integers. So going on with data types, there's also Boolean, which is a true or false. So you literally write something like, you can create a variable here, so you type its data type, which would be bool, and then you type the name of the variable you want, and then you assign it to some value, which could be true, or it could be false. And that's how you would make a Boolean variable. And so that's that data type. And then you have characters, which are simply very unique characters. So for example, you type char for character, and that's the data type, so test. And you want to use single quotes and then type anything that's on the keyboard. So for example, you can type 9. Now, is the character 9 equivalent to the number 9? No, it's not. And I can test that by just doing an if statement here. And this is going into some more stuff here, but we'll do this anyway. So if we were to test So I wrote that little group of code there, and then we're just going to test and see if they're equivalent or not, which I'm pretty sure they're not. And I forgot a semicolon somewhere. And then they are not equal. And the reason for that is because the integer value of the character 9 is different than the actual integer 9. These are all masked to an ASCII2 table, so you can go on the internet and look for ASCII2 character table. And so this is the character set, so this is the character A, and the value of it is 001, and it continues like that. So the character we had was the number 9. We have to look for that character on here. So here's the number 9. It's actually the character 9 actually has a value of 57. So if we were to edit our program and say the character 9 is equal to 57, and save that, compile that, execute that, enter our stupid number, they're equal. So that is kind of a short breakdown of characters. Each character is unique too, even if they look similar. For example, the number 1 and the letter L look very similar. They're all unique, they are different. So floats is a number like 1.0234, or you can write pi, 3.14. That's not pi. 3.14. I don't remember any of the others, but that's a float. It goes into a certain precision. My professor always told me to stay away from float. Always use a double. A double has a higher range of decimals that it can hold, and as a result, it's easier to use a double consistently. If you do end up using float, you need to make sure you're consistent through the program, because these two data types differ in the amount of information they can hold. This one will hold more decimals, more trailing decimals. This won't. And many people want to use this for currency because it rounds nicely and using up to a certain dollar amount. And as a result, things can be off by very slight amounts. So it's important to stay consistent with your variable choices if you're dealing with particular types of data, like currency. And then I wanted to go over one of the last ones here, which is string. String is actually a class that you have to import. And to do that, let's see if I remember. You have to import string.h, I believe. It's a C library, so it allows you to do all these different functions, which either return values or they return pointers to different values. And this allows you to make a length of characters connected together. So instead of just having one character, you could return a whole string of them. So you have like this fixed array of characters already built for you. So an example of that would be, let's go back over here. We have to import the string.h header. So we will go here, and I accidentally opened Atom twice. Apologize about that. And then we will go include. So we have the string class now, and then we're going to make a string variable. So we give the data type, which is string, and then our variable name, and then we can assign it to some value. And this website, while I'm on this website, is pretty good for learning about various things. I've used it in the past. I like it a lot. I'll link it in my tutorial video here. So let's go ahead and make sure this compiles. Still compiles. We still execute it. So now what we're going to do is just see out. Save the file, recompile the file, execute the file, my first string, there you go. So that's how you use strings in C++, is you have to import the header, the string.h, and that's it. And that's all data types I want to go for right now. In the future, you'll learn how to make your own data types using classes and structures. Thank you for watching.